So, good. So just in case you don't know me, I'm Matt Thomas. I'm a principal software engineer for the UI team at NEC Energy Solutions. Essentially, day in and day out, I do Angular. A lot of JavaScript. One of the products we have is a dashboard and a monitoring system. So there's a lot of charting, graphing, mapping, that kind of thing going on. So as soon as you get into that realm, your managers start saying, can we do things pretty? And then you get into things like SVG. And everybody know what SVG is? No? Okay. So we actually have two SVG images on the title screen itself. This vertical lettering here that has all the squiggly lines, that would be a pain in the butt to render as HTML, CSS. The only real way to do it would be an image, and then you would have an image loaded on every page. That is actually SVG with a filter on it. So it's literally just rendering a font with a filter over the top of it. The other SVG image is the 5 logos. Each one of those is the exact same logo. You'll find out that one of the advantages of SVG is it doesn't lose clarity. So the big one versus the smaller one, you should be able to tell. The only difference you're going to get out of it is the projector being able to render the pixels. So anybody in here use Font Awesome 5? You're using SVGs. So what is an SVG? It's an XML-based vector drawing format, vector image format. Now what that means is it's two-dimensional. It doesn't support 3D. You can fake it, but you got to be pretty clever to do that. And it supports interactivity and animation. And it is part of the spec that the W3C has released. SVG's been around a long time, a lot longer than people realize, I think. Some of the advantages, as I mentioned before, scalable and responsiveness. As you scale it up and down, it really doesn't lose clarity. So you can have a finite detail in a image and not lose any of get pixelization, or either when you take it down or up. I'm sure we've all messed with that. Can you put this image on the page? I need it about, the background. And it's like 10 by 10 pixels, and when you use it, it's all pixelated. That's not very nice. So designer friendly. A lot of designers use Illustrator or Inkscape or other vector-oriented programs. They can actually export an SVG really effectively. Performance and bandwidth. SVGs can be used inline. They're XML, which is kind of close to HTML, So, and HTML supports SVG inline. So you don't have to make a separate HTTP request to get your image. It's brought down with the original page request. And due to the fact that it is a text definition, you can compress it. So instead of having a PNG image or a JPEG that's compressed as small as it gets, you can compress this down pretty good, so it reduces bandwidth. Because SVG is XML and it is actually imported into the DOM, you can manipulate it and style it using JavaScript. There's a caveat with the styling with CSS, but you kind of got to trip over that one by yourself. We'll talk about it, but some things you can apply via CSS, some things you can't. Browser support, we'll talk about that next. All modern browsers support it for a long time. Accessibility, so if you have a very complicated image that you need to make ARIA, have ARIA support on it. Because it is XML, you can just put them right in there. And then it'll, the screen readers will handle it right in line. Why not use SVG? First off, if you're going to use Internet Explorer, your support is limited. On legacy support, it does require a fallback image, which isn't very pleasant again. You get back into the downsides of that. If you have a complex SVG, imagine trying to render a HTML page that had thousands of elements in it. Your browser is going to bog down a little bit trying to render that. Well, SVG is similar. If you have a lot of nodes in your SVG, it's going to try to, first off, grab that real estate on the screen, plot out all the coordinates, and then try to render all those nodes and filters and paths and curves and all that stuff. So if your SVG gets too complex, then you're going to have performance issues. Animation can be have a lack of performance as well in SVG if, again, you get a little bit too complicated with things. You'll kind of see what you can do within the realms. I got a good example from Sarah Dreschner that's a really avid SVG speaker. I stole something from her. So here's the support. As you can see, all the modern browsers support it rather readily and have for a long time. Even Edge. They finally came up to speed. So using SVGs, just like images and other HTML elements, there's various ways of implementing them. You can literally use all of these things. This is what we're going to go over. So you can include an SVG right in an image tag, and it will accept it and import it right in and use it. You don't have to do anything special. You can go out and source your SVG and put it right in an image tag, and it will come right in. This is actually a rather complex SVG. You can see all the complex gradients and things like that. Let's see if I can, if I were to, no, it's going to. Okay. So that's one thing about SVG is it might not zoom in or zoom out because it is literally pixels on the screen. So it doesn't scale very well all the time. There's ways around that, but you got to go about making sure you're in that mode. So you can also include SVG inline, which means literally in a div, just chunk some SVG in it. This is very rudimentary. There's quite a few properties or attributes that potentially are missing that would make this a better representation of an SVG, but it is what's rendering down here. All I did was create an ellipse and gave it a stroke of 2 and stroke width of 2 and gave it a stroke of goldenrod, and then fill of gold. And then these are my XY coordinates that are necessary to build the ellipse. And then they stack on top of each other. Okay? Yeah. CY, CX, we'll talk about those in a little bit. No, you're fine. But those are the coordinates based on the dimensions of the SVG, which we determined was 400 by 200 in the height and the width. And ViewBox we'll get into as well. This should look familiar because it was mimicked after our full stack logo. Yeah. So it was a simple example of how to do that. That's a very simplistic example of handwriting some SVG. Coordinate system. You will find out that SVG, the coordinate systems, is very important, and it's probably one of the biggest things you'll fight with to find if you're going to handwrite it, you got to put everything in the right place. The coordinate system starts at the top left corner, and it works positive to the right and down. If any of you have ever had CAD experience, that's completely wrong, but that's how the browser works. It assumes that you're going to read from left to right, and you're going to read from top to down, so that's the way it draws. The overall coordinate system it uses integers only, and those units are pixels. So you don't really get too much of a choice on your initial setup. I don't know too many things that don't work in pixels though. The pixel units apply to all the positional and dimensional attributes. That's almost right. You can use percentages as well. So if you want to put it dead center, you could put CX, CY at 50% in both of them, and it'll put it in the dead center of your screen real estate. So, or the designated the box you're going to use. Okay, ViewBox gets a little bit interesting. So if you think about a XY grid in pixels, that's what you start with, and then you put a ViewBox over the top of it. Well, if you make the ViewBox the exact same size as the palette, we'll go with that term, it's essentially no different. But what I can do is I can make the ViewBox bigger than the canvas itself. So here we have a SVG that's marked out at 100 by 100 and starts at 0, and then it goes to 100 by 100. Then the rectangle, it takes up 100%, so you can see it's taking up the full screen or the allotted palette. Then it's got a circle in the middle that is XY 50%, so it puts it in the center. The radius is 4, and the fill is white. Okay? Now, with the exact same image, and just a slight variation in code, we can make it look completely different. All we've changed was ViewBox is now 10 by 10 instead of 100 by 100. And so when our circle comes in at 4, it now takes up a significant portion of my ViewBox. So you get to scale your SVG by using the ViewBox. So I guess the best way to do it is you have your canvas, and your ViewBox is like your camera you're looking through, or your viewfinder, and you can either make it as big as you want, and you can also move it around. So what I can also do is I can move that viewfinder, the ViewBox, off to the side. So what you see here is I have the exact same size. Well, it's actually a little bit bigger, but it starts at -5 and -5 and goes to 10, 10. So now that exact same circle and square are cut off in the corner because I moved my ViewBox up into the corner. I've seen some presentation softwares where they create all their slides in the SVG in random places, and they literally animate moving the ViewBox from one place to another, and that's how they render the slideshow. You can do some pretty interesting things. I tried to use it. It's a pain in the butt. So MDN has a lot of resources on SVN. So if you want to follow along, the bit.ly is up in the corner. And there's links throughout. All these presentations or all these things are interactive, and there's a couple more coming. So, and no, you can't control mine. Okay, questions on ViewBox? Kind of get the concept? It's a little bit of a challenge. Sometimes it doesn't act the way you would expect it to. It's something you got to wrap your head around. At least it was for me. Okay, you have basic elements, drawing elements. These should look familiar for the most part, from elementary school. All your basic drawing elements. So to do those, here's an example of each one. Your x1, y1, x2, y2. It's essentially just going to start x1, y1 is up here, x2, y2 is down here. It's just a direct translation of draw 2 points and put a line between them. Circle, cy, cx is your center location. And then your radius is the number of pixels is your radius, right? Basic elementary school. And then the ellipse, you get a little bit different. Your Rx and Ry are this dimension, each appropriately. And then your rectangle is you top left corner and you tell it your width and height, so it's a little bit different. You start at one corner and you push out. The Rx, Ry is actually your radius corners. So you could have an elliptical radius corner. So if you didn't have these consistent, so if it was 5'10", you could make it kind of go and make it a little bit longer or flatter, however. Polygon, it literally is a series of points. So these are XY points, so it might start here and then just draw a line all the way around. And then there's a polyline. What you'll notice is when I draw this polygon, I actually stop here. And by default, the polygon will close itself. So you get that last line for free. You don't have to declare where it goes. The polyline is a non-self-closing version of a polygon. You can make this thing go any way you want, and it doesn't have to come back to itself. So, and I have fill in all of these just so you kind of get an idea what's truly being drawn. Like a polyline probably wouldn't have a fill in it. Yes, sir?
So the polygon, the final side of it is just automatically filled in?
Correct. Yeah. So I believe 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then the seventh line is, or sixth line, but it's automatically closed, right? Whereas the polyline will not do that. Okay? So if you're drawing a chart, you want to draw a polyline. You don't necessarily care about fill, and you don't really want it to come back across to the beginning. So that's how you would draw a line chart or something like that. Okay? Questions? Yes, sir.
The polyline also comes in handy with some messier Illustrator or like rendered SVGs that will have those depending on how the design made it.
Yep.
It kind of allows those to be identified a lot easier.
Yep. Path. This is a little bit of a interesting one. A path, the D is definition from what I can gather, and it has commands. So you move the cursor to 1030. So let's say, that's we're at one of these points. But then you're going to get an arc that goes from 2020 to, and it has attributes of 001, and it ends at 5030. So that might be one of the tops of the heart. And then you got another arc that's moving essentially the same direction, or the opposite direction, because it's going to 9030. And Q is the Belzer curve, so I suspect that that's this nice side non-traditional arc. Anybody know what Z, well, here it is right there. Z is actually where you get to close the path. You don't have to tell it to come back to the exact same point. You just say close and it'll find its way home. These are probably one of the most complicated things. If you use Illustrator or some other piece of software to generate your SVGs, which we'll talk about a little bit later, paths become very much easier to create because you're literally using mouse user interaction to build them. So you'd actually be kind of surprised at how hard it is to create a heart like that in Illustrator. It's not exactly straightforward as you think, especially to get those nice bells or curves on it. You can also, this looks very reminiscent of an HTML image, but image tag, but it's actually an SVG image tag. So if you wanted to integrate an image inside your SVG for some reason, you can do that. So you can actually have a complex part of the SVG be an image and then have everything else around it render. Or you can put an image in it and have something render over the top of the image. Okay? Like arrows or who knows. Yes, sir?
Can you use the image tag as a fallback?
Uh,
Would it render as an image?
you wouldn't use this image tag. You would use a fallback, HTML fallback. So there's ways to do multiple sources for an image based on its support. So that's an HTML thing. So I've never had to support it. I left Internet Explorer behind a while back. So as you can tell, I have an affection for it. So you say, what if I have a bunch of elements on the page that I want to manipulate as a single thing? You could imagine how hideous this would get if you had to grab everything every time you wanted to manipulate it, right? Well, SVG's got something for that. It's called group, or G. You can tell it's been around a while because one-letter tag names were perfectly acceptable back then. You essentially put a group tag in, and it will consolidate anything inside that group into a single unit. You can apply attributes such as fill, stroke, whatever. So if you have a bunch of circles, so I could have used group on my pancake, and I could have applied the yellow, the coloring, and the stroke all in one fell swoop, just applying it to the group, and all the children would have inherited it. Okay? That would have been a much better example, except for it's not very elementary. Attributes are huge in the SVG ecosystem. Pretty much everything is dictated by the attributes that you put on a particular element. Attributes provide both styling and interactivity. So some attributes can be applied, all attributes can be applied directly to the element. Otherwise, you can use CSS for things like coloring, fill, and things like that. There's some properties that the CSS standard will allow you to apply, some are not, like X and Y. I don't think I've ever been able to apply X and Y to a SVG through CSS, even though that would be freaking cool with all the math you can do in SVG, or in CSS, okay? You could do transitions and things like that on it, CSS transitions on it. You wouldn't have to do SVG transitions, or transforms. So again, X, Y, Z needs to establish the coordinates. Z traditionally is used for locating light sources within filters. So there really is no, it's only 2D. The Z only allows like the intensity of the light that is being applied by the filter. That's essentially what it is. So draw order matters. As you noticed with my pancakes, I didn't really dictate that one pancake should overlap the other aesthetically speaking. All I did was draw them on top of each other, and it naturally flowed in that way and presented itself. So there really was no effort in making one thing hide behind the other. It's literally the order in which the SVG is drawn. So the order of your elements in your SVG matters. If you're using a imaging software such as Illustrator or Inkscape, there's always a function in there that says move up, move down, move to top, move to bottom. That's exactly what it's doing, is literally just moving that element up and down in the XML structure of your file. Bottom to top. Nope. Are you talking? I think it draws top to bottom in the XML. What?
The one pancake you had that wasn't covered, was that first in the XML or last in the XML?
I
It goes from the back to the front.
The next element is always drawn on top.
yeah. So as you read it, you would read down, and it would become on top, because the last element rendered would be the last. Yeah. So if I would have reordered these, it would have looked backwards, because the one on the bottom would have been completely visible, and it would have looked funky, because that's not really how physics works. So again, the X and Y come in different variations, such as X1, X2, just depending on the element and the needs of the particular element's use of the coordinate systems. One thing you need to worry about is when you do transform. So if you transform something 90 degrees and your X and Y is like this, your X and Y is now like this. So when you go to move that thing on the X-axis and it goes flying sideways instead of down or whatever, you're going, what the hell's going on? That coordinate system got modified for that specific element or group. So you have to be careful when you start using transforms. I actually use one later in the presentation, and I'll let you find out where it is. See if you can pick it out. It's not evident by any imagination. So fill does exactly what you would expect it to. It literally takes the outline of the element and it fills it with whatever color, be it transparent, white, black, whatever color you use. You can use all the HTML words, color words, and you can use the hex stuff as well. So the fill does not overflow the stroke size, and I'll explain that here in a second. And it also defaults to black. Okay? Stroke. Strokes straddle the outline that you define. So if I have a 2 by 2 square, but I have a border of 2, now my box is 4, because it's 2 by 2 plus it's one outline and one outline edge. So now it's actually 4 wide, 4 big. It's rendered as 4. Does that make sense? So the stroke you draw will straddle the dimensions you have and make it bigger by one stroke width. So if you're hand drawing it, you have to take that into consideration. Okay? And default stroke is none. Stroke dash array is a given property on any line you can come up with, and you can do some pretty killer things with it. I got a smile back here, so somebody's played around with it. What's that? Yes, it is. So transform. This is a very powerful thing. It defines a list of transformations that can be applied to an element or element's child. Keep in mind that a group is an element. You can apply it to any number of elements all at once by just grouping them. So if anybody's familiar with doing matrix transformations, you can do all kinds of garbage with this. Translate just moves an object, so that's literally animating it side to side, up and down, or any direction. Scale, rotate are kind of obvious. Skew X, skew Y, it literally takes it and kind of makes it polygonal. You can kind of make a cool 3D cube by using skew X, skew Y. You draw a rectangle and then skew it, and it makes it look like it's 3D and that kind of thing. And if you get real sophisticated, you can get it to rotate and do some weird, funky things like that. Like I said, if you're really good, you can fake it, fake 3D. You just got to act as if it's a piece of paper and how would it look in every snapshot. And then you got to animate that. So, questions regarding transforms? Okay. Here's a little hand-drawn SVG I built. I'll show you how I did it here in a minute. But they have interactivity. So you can manipulate your SVG. By the way, this is my transform. Does anybody know where my transform is on this page? Any wild guess? Shut up, Bradley. What? The center of the circle? This one? Not quite. So if I told you that SVG circles start at 3 o'clock and go to 3 o'clock, counterclockwise, but I want my chart to start at 6 o'clock and run to 6 o'clock, because that's how people read most gauges, right? So I had to rotate my gauge circle by 90 degrees to get it into a position that it started down here and would go all the way around. Okay? So this might be why you want to open up the bit.ly, because you can actually click and play with it. So if I clicked on the percent battery, there's another application for this, but I can't go into that. But let's imagine that this is a car, electric car, right? It's got a battery. And we need to know if it's got any alarms we'll go with, warnings. And what the maximum severity of the alarms is, and whether it's discharging or charging. So if I change the battery percent, you can see that it's actually manipulating the stroke dash array to make this fill and charge and discharge. Okay? Now you'll see once I get down to 15%, we're in the warning area, so we change the color of the line just using CSS to red, because now you need to get to a fill station, right, a charge station. As well as you can change the alarm count. You can change it. Got a critical issue. And you could do all kinds of things. You'll notice that when we went to critical, the color of the text changed, as well as the background of the center location. So all this is being done either via JSON or JavaScript or CSS. I actually use a very similar pen that I draw on a map box. I use as a map box marker. So we have these electric cars all over the world, and we need to monitor their position and their status. So we essentially draw this SVG in real time on the map, and it updates these in real time as it refreshes. My boss asked me if I could do this. I said, give me a week. And he's like, really? It's going to take that long? I'm like, get over it, dude. You don't know how complicated it is. And the one other thing we did is once you go down to 0 alarms, it removes the severity because you don't have any. So again, the only little caveat we had on, this is a stroke. The green line or blue line, depending on which direction it's going, is a stroke. So it's a circle with no fill, and I think the stroke on this big image is like 60. So, and you ask, well, why does it only go around? Well, we'll show you some code here in a minute, but I measure the circumference in pixels of this circle. So if it's, let's say, 1024, it's somewhere in the neighborhood of that. It's a nice round number. And I say 41% of 1024 is, 400 something, right? Ish. So my stroke dash array is 400, and then I use the total circumference to block out the rest. So how stroke dash array, it says, give me a line this long, then give me a space this long, and give me a line this long. So the array is like Morse code. short, long, something like that. So what you do is you make the one number the length of the dash you want, and then the rest of it you just make it way too much, and it'll push the dash off the end and out the other side. Does that make sense? Questions about that? You can do some pretty killer things. They're doing SVG scroll bars, or progress bars, and it's just whoop, whoop, and you can, the ones that are on the screen and then they close up and then they start up again, they're doing stroke dash array to make it go full length, and then they're pushing the dash or the space, and then they're pushing the dash again. You can do some pretty funky things with it. You can make it go in, you can make it go out, you can do all kinds of funny things. If you've ever seen an illustration where somebody draws an actual drawing in real time, they're using stroke dash array. They just draw a single path that draws the whole drawing, and then they just push the stroke dash array to fill in the whole thing in an animated fashion. That's how they're doing that. So if you see somebody handwriting, it's just an SVG stroke that they're pushing the dash array. All they're doing is gradually adding length to that dash on that path. It's pretty killer stuff. You can do some pretty cool stuff. This is a very basic example. Still got the job done for me. Let me go ahead and guess what? I closed it out. Everybody can read that, right? Oh, come on. Okay, Bradley, what's my shortcut key? Let's see how bad this is. That look good? So I have an update pen, and all I have is a click handler on each button, each one of my form buttons. All it does is it executes update pin on change. So then it passes in the event. I get the ID of what button was pushed, and then I process the change. Now this looks a little bit more complicated than probably what it is. The line 34, I'm just getting the value out of the percent, the slider. So that would be between 0 and 100. Then my diameter of my SVG is 350. Then I'm calculating the circumference, so I know how long my dash needs to be. Then I have a threshold. There's my 15%. So when I get below it, I'm going to go red. The new value, so I'm storing the old value, the current value, and the new value. So the gauge percent is calculated. So that's where I get the actual length of the arc, the dash. Then I grab a couple of elements from the DOM. I set the, I set the current value. So I get the battery gauge, and then I'm going to set the attribute of stroke dash array, and I'm going to split it with the separator on current value. So stroke dash array requires at least 2 numbers. I only want to set the first one. So I'm using my current value as, I'm getting the current value so that I can tell if it's going up or down. So I grab the current value out of the stroke dash array, and then I've got some classes here that I'm building, whether or not it's charge or discharge. That changes the color from green to blue. So, and then down here I'm applying those classes down here, where I do prefix, set the class to prefix. And the big one here is I'm going to set the stroke dash array to my new value, and then To make sure that the dash doesn't ever come back, I just set it to the circumference, which makes it go all the way around. Makes the rest of the arc disappear. That's just for the top one. So if it's the input count, all I do is grab a bunch of, I grab the value. I grab the value from the event, and if it's equals 0, I change a bunch of properties, remove all the severities, and change all the colors back from dark to light, or light to dark. That one's pretty simple. And then for the severity input, if it's critical, then I change everything to light text, and if it's not, I change it to dark. And then I update the class names to change it from red, yellow, or red, orange, green, or sorry, white. So that's literally all it is. It's just a bunch of DOM manipulation. There's some CSS involved as well. Oh, golly. Yeah, this particular, that example is inline SVG. So you'll see in the next slide, I draw it again using JavaScript. Or not the next slide, but here shortly. There's some SVG. So down here, if I get into the right one, sorry about that. This is just a nuance of the presentation software I use. Oops. Oh, of course. So you'll see here I have so the light text, dark text is just literally fill black. Opacity you can apply to the SVG. So when I go back to it, you'll see that the percent in alarms is actually 80%, and it's actually over the top of the numbers, so that it's always there. You can apply font weights. You can apply font families to your text inside your SVG. Font sizes. These are literally, they look like HTML styling, but they're actually SVG. Because they're kissing cousins, they essentially, thankfully, stayed close to the same stuff. So here's my transform. Up at the top, I drew my gauge, and then I had to transform it 90 degrees. So I rotated it 90 degrees. And because I have a pen, so the circle is not in the middle of the drawing area, I had to disproportionately change the center of rotation. So that's what the 42% transform origin is it's establishing the pivot point of my transform. So when I did this for the maps, it was a itty bitty little SVG. When I blew it up to do this, it was quite of a challenge to find those new center points. And then essentially the strokes, this is where we're changing the strokes and all the properties on the various classes on the SVG that needed to be manipulated. That's pretty much it for that. Questions regarding that stuff? All this is, you can inspect the source on the slides if you would like. And again, as you can see, the percent is 80% transparent, and so is the alarms right over the top of the other text. Yes, sir. Yeah, I did forget to mention that, yeah. So to reiterate what he's saying is if you include it with an image tag, it literally treats it like an image and you can't modify an image. So using JavaScript, it's literally drawn like a canvas. You can't touch it. So yeah, in order to be able to manipulate your SVG, you have to actually import or have inline SVG styles. It's also another reason why my boss didn't like it, because we literally had to draw SVG for every pen. He thought that was, just create one, put some text over it. No, it doesn't work like that. So, our presentation controller is. So this is let me reload this. 5. So at the end, I'll recommend that you, if you're really interested in SVG, Sarah Dreschner, Sarah Ito is her handle. Spent, I think, a year or two just understanding SVG to its infinite degree. Spent a lot of time, did a couple of years worth of circuits. That is my computer. This may look familiar with a little robot computer that had a little cricket friend. And she created this SVG that is very interactive. As you can see, he is always trying to get to or observe his cricket. And every once in a while he gets vocal based on how much you agitate him. Or if you let him set, I believe. He gets agitated. And so as you can see, she's doing a whole bunch of mouse tracking and things like that. This is all SVG. So, and what if you did notice before I reloaded, there's some issues with Chrome and animation and the fact that I'm using a code pen. His head would fly off his neck if you don't load it correctly. So that's just an example of what can be accomplished with SVG. It is a rather complex transforms as the mouse moves. It's not exactly a straightforward implementation. His arms stretch out. I don't know if you noticed. They change direction. His face changes direction. The wrists bend out. There's a lot of subtle stuff going on here. Well, yeah, you can look at it too right here. Just the source for the SVG alone is amazing. So you can see here, I just lost it. Group for the right arm, and she's drawing a path, and then she's got a clipping path because, you know, we want to make this go back in, but it can't clip over the shoulder or the elbow when it moves, so it's got all kinds of, there's all kinds of complexity built into this. The right arm, then we got above it, there was a back wheel. So this back wheel.
So that grouping of the right arm,
Yeah,
where does she close that out?
it would be right here.
Okay, I didn't know if that was.
One of these. Yeah, I would think it would be that.
I didn't know if it was the clip path.
Clip path is that's actually, as you can tell, it's kind of complex.
Yeah, so I didn't know if that right arm was maybe further down.
Well, this is backhand. Yeah, it looks like it's farther down. She's grouping a clipping path here. Looks like she maybe unnecessarily grouped it. Oh no, she's using some URLs to get some things going on there. So there's some nuance in there that maybe I don't necessarily even understand. It's a very complex example of what can be done with SVG. So it's one of those you can't really pass up when you see it. So, and as you can see now, he had his hand over his face. So now that's a clipping path there. He's got his hand over his face. And I'm going to close the HTML, and this is a perfect example of what SVG does for you. If you could zoom in on this, you would notice that it doesn't lose any of the clarity, the line definition. I mean, it's harder for the screen to render it, but you don't really notice any difference in display. I think he's messed up a little bit since I'm messing with. Oh, maybe it was just the position of his head. So, if you're seriously into SVGs, I would recommend that you look up Sarah Dreschner. I got some links at the end for you. So, okay. JavaScript libraries. So you saw an example of me using raw JavaScript, just using, just manipulating the DOM. There are some JavaScript libraries that specialize in doing SVG manipulation. It takes us some of the nuance out of manipulating some of the SVG elements. It makes it a little bit more straightforward and puts a little bit of icing on the cake so that you can draw things a little bit quicker. GreenSock is one of the popular ones that for more complex stuff. Snap SVG, I personally use SVG.js here momentarily. I use it at work as well to draw my pins. GreenSock's actually a pretty decent sized library. It was kind of overkill for what I need, so I didn't implement that. There was also Raphael, but that's a little bit outdated. And if you've ever used charting libraries like D3 or NVD3 or Matrix Graphics or Bright Charts, they're all rendering SVGs for you. You don't know it, but you are. So you'll see that they can manipulate things a little bit interestingly that maybe some HTML charting libraries can't do. So here's my SVG.js example. Looks familiar, right? Again, this is a stripped down version of our car icon. And as you can see, we're grabbing a div and we're creating an SVG container with the size of 42 and 55, which is a little bit more reminiscent for drawing a map pen. Then we create a path here. What that path is actually the pointy part. It's just a triangle that closes and is black by default. It's actually stuck underneath the ring, and it's drawn first. This answers your question. So first goes on the bottom, and as you go down your SVG, it gets stacked on top of it. So then we're going to draw a circle, and it has a class of gutter. I can tell you that the stroke width is defined in there. So this gray circle here would be the gutter, so that it always shows up. If I didn't have the gutter, whenever the line came back, it would show transparent or whatever's underneath the pin. So you need, in my case, I wanted a gutter there. Then we draw again using the same algorithm that we used before with the stroke dash array. We draw the gauge, and then on the inside the alarm severity circle and alarm count. Yeah, here we're setting the alarm count. Oh, what's the worst thing you ever tried to do in HTML? Center text in dead center of something? It's atrociously horrible, right? You can do that absolutely with SVG just by telling it, I want to anchor in the middle of my text. That's all you have to do. Puts that anchor point right there, and no matter how big or small you make it, it just stretches out from the dead center. Super easy to make center text there. Then we create our text object and output it. Oh, there was another text object in the original that had an icon right there, Font Awesome icon. And that's essentially an example of how to use SVG.js to do the exact same thing. Now, that looks kind of complicated compared to what I maybe some SVG I had to draw. I could do this in 5 lines of SVG, but if I'm doing this 100 times on the same page, I need a kind of a function to drop all my variables into. And that's essentially what this allowed me to do, was I wrote one function that took in all the values, and all it did was render each pin in its own position. So the map even took care of positioning it for me. All I had to do was tell it what pin to render. So all I had to do was feed in the attributes, and it did the rest. Okay? If you're curious, Mapbox or Leaflet. Both of them handle it rather well. Okay? Kind of geeky? Questions? Okay. Or were you looking? Okay. Okay. Sourcing SVGs. SVGs are all over the internet, just like everything else, like cat pictures. Okay. The best way I found for Google is you go to the Images Advanced Search and you tell it type SVG, and it will eliminate your search down to only SVG type. So, and I believe these are all links, so you can actually click on this and it should send you to an example of what I'm suggesting. So there's Open Clip Art, there's Noun Project. These are pre-drawn SVG files that you can download. Font Awesome, again, Font Awesome 5 is nothing but SVGs nowadays. Simple Icons and Glyphicon. Vector format files, they're really easy to convert to SVG. I did list PDF because PDF will store a vector format for you. It depends on how the PDF was created, whether or not it has vector information in it. You could have a nice Illustrator and it export to PDF, and in the process of exporting the PDF, it converted it to a raster image. You're screwed, sorry. You got to go back to the original source, okay? PDF does have the ability to store vector images, though, along with DXF and DWG, which are both CAD software. I have a history in using CAD, so ESP or EPS and DWG and DXF are very valid forms of creating vector formats. The reason why I bring these up is a lot of technical things, maybe such as schematics or things like that will come to you in DWG or DXF form. You can get converters that will take those and put them in SVG, and you can plunk them right on a website. You don't need a viewer. You don't need nothing after you convert them to SVG. Again, be careful of your complexity when you start getting into things like technical drawings, because things stack up real quick, okay? You might have to get a stripped down version of that to display on the page.
This is probably a weird question, but if you had a PDF and converted it into SVG and then tried to minimize the file and just compress it, would you end up getting a better result than what the native kind of PDF would be, or do you think it would?
I'm not real sure. I guess it would depend on the contents of the PDF more than. I'm pretty sure Adobe's worked pretty hard to get PDF levels to a reasonable extent. Not real sure about that, but potentially it could, yeah. I would say that would go either way, just depending on the contents of the PDF. So vector graphics editors. Again, I mentioned this a couple of times already. Inkscape is the open source version of Adobe Illustrator. I tend to lean toward Inkscape, mostly because I don't want to pay Adobe for Illustrator, and Inkscape gets me there most of the time. Okay? Illustrator has some awesome features. If you have a Mac, I'm sure you've heard of Sketch. Us PC users don't have a clue what it is, sorry. And Google, if you need something super simple and you already got a Google account, you can just open Google Docs and go into a drawing, and it will create you a nice little vector image. You can export it straight out in an SVG format, and you're good to go. So like if you needed to create a org chart or something like that, go in, draw some boxes, put some images in it, draw some lines, wham, you're done. Okay? They might actually already have a template for it. So one of the things you want to be careful of when you're using one of these creation methods specifically, Illustrator and Inkscape, they don't really, and I'm not familiar with Sketch enough to know if it's the same way, but they don't really care about compressing their or optimizing their SVG form, their vector formats. So you will find that they're bloated. Anybody ever open up a Word doc and it's like 64K with nothing in it? SVG can be the same thing, okay? You need to, I recommend that you run it through one of these optimizers, and it will go through and take out all the unnecessary tags, metadata, those kind of things, and reduce the size of your SVG so that you're not just sending unnecessary markup across the net. So one thing I will caution you about is just like an image, when you try to start compressing it and you get it down into the 40% quality range, things start disappearing or not looking like what they should look like anymore. These SVG optimizers have the same scenario, where when you start optimizing them too much, that curve might now be a straight line because it took out too many points. Okay? So be careful how much you optimize. You get mixed results depending on the image you have and how much you're trying to optimize it. So again, Sarah Dreschner's got an excellent article on high performance SVGs. She kind of tells you how to walk that line. So again, people you should follow, the two Sarahs, Sullivan and Dreschner. They're both very adamant about using SVGs, and they've done quite a few experiments and some talks. Also, MDN. I don't know if you guys are familiar, but MDN is like the official internet documentation. Microsoft, Google, and Firefox have all gone together and said MDN is the right place to go. So if you need to find out about HTML, JavaScript, CSS, or SVG spec, that's the place to go to get the official word. Okay? W3 Schools ain't it. Okay? CSS Tricks has some awesome articles about using SVG. SitePoint, it's valid data. You take it as you get it. And then just an opinion piece about why aren't you using SVGs. Questions? No? Okay. Here's some information that we shared this morning or earlier. If you want to get a hold of the meetup, here's STL Tech's website. You can join the Slack channel, and then here we are on that Slack channel. Here's my contact information if you need it. If you have any questions, got any concerns trying to do SVG and Lost, feel free. Thank you. And just to make sure everybody did sign in, please.